Hello everyone, I am Saurabh Ailawar. I am a PhD student, fourth year in the Chemical and Biomolecular Engineering department. I am working with Dr. Umit Ozkan and my topic is destroying water contaminants with swellable organically modified silica. So today I'm going to tell you the story of my research, which is based on making and using a novel material for cleaning up water which is contaminated with organic compounds. Now we all know that oil tends to float on top of water. It doesn't like to mix with water, it dislikes water. And we also know that there are certain powders that can do the same. They don't tend to mix with water, they don't sink in water, they just simply float. So does it mean that if I take this powder and add it to this system, the oil will mix with powder, leaving the water away? Just like enemy of an enemy is a friend. So in the same way, it turns out that it does. So our work is based on using a material which is made with some silicon and carbon containing materials and which is hydrophobic in nature. And what we do is we dip this material in a stream that contains water and organic contaminants. And these organic contaminants, just like oil, do not like water. So these contaminants find their way in the material that we have made and thereby leaving the pure water. So what is novel about the material that we have made? Just like when we eat food, our belly tends to stretch. And after a certain time, we get full and we stop eating. In the same way, our material tends to expand as it takes in more and more of these organic contaminants. But that material also gets full after a certain time and it stops taking these materials. So what we tend to do as catalysis engineers is we incorporate certain active centers inside this particular hydrophobic material that we have made, so that once it takes in these organic contaminants, it can convert it into harmless contaminants and send back in water. That way we purify water. So instead of getting full, it is converting it into harmless contaminants. Now there is one challenge while using this technique. We know that water has a lot of salts in it, all sorts of water, groundwater, seawater, it has a lot of salts dissolved in it. And these salts tend to deactivate these active centers that we have incorporated in the material. But as I said, enemy of an enemy is a friend. The salts like to stay in water, they have a natural tendency to be dissolved in water, but our material, our active centers are in a hydrophobic material that hates water. And as we know, like likes like. The salts like water, our material hates water. The salts stay away from the active sites and thereby the active sites are protected. So my entire thesis is based on studying and utilizing and developing these materials to treat water that is contaminated with carcinogens and other pollutants. Thank you so much.